Hello friends, welcome to my YouTube channel, International Academy of Physics. My name is Pravesh Chauhan and I'm a physics teacher. I have been teaching physics for more than 16 years in India and abroad. I have taught US, UK and CBSE curriculum. Nowadays I am teaching IGCSE, A, AS level physics, AP College Board Physics, IBDP, SL and HL and the CBSE physics. So today I plan to discuss one topic, that is electric charge and Coulomb's law. Before I start this topic, let me show you the content which I am going to cover in my YouTube videos. So if I start with the Cambridge board, in the Cambridge board I will cover the IGCSE physics part, all these chapters, and for the AS and A level physics, these are the chapters which I'm planning to cover in my videos, both AS and on the right side, this one is the A level physics, including some chapters from AS. And the CBSE physics term 1, all these 4 units I will cover in my videos, and rest other 5 units in term 2, which I plan to cover it. So at the same time, I'm planning to cover the College Board curriculum AP Physics 1, AP Physics 2, AP Physics C, both mechanics and electricity in the magnetism, both the parts, the complete content, and the IB Physics, SL and HL. So if you want me to make a video on a particular topic of your choice, you can send it to me or you can write on comment box or the name of that topic so that I can make the video on that particular topic of your choice. So within a 1 or 2 days, uh, I'm, I will upload that video. Okay friends, let's talk about the electric charge. Under this topic, I'm going to cover these 3 things. Electric charge. Second one is the charging by friction. And the third one is the Coulomb's law. So in the first part, we'll cover the electric charge and its definition, its types like positive or negative charge. Then charging by friction. We have a 3 process: charging by friction, charging by induction, and charging by conduction. So charging by induction and conduction, I will make a video later. And third things which I'm going to discuss today in this topic is Coulomb's law. So why Coulomb's law? Because in this process, charging by friction, the objects get electrified. So when the charge they get electrified, they may have positive and negative charges over there. So they will experience the force of attraction or repulsion. So to calculate the force of attraction and repulsion between these two charge bodies, we can use Coulomb's law. Okay, so let's take one by one, starting with the electric charge. So as we know, everything is made up of matter. All right. So what is electric charge is this? It's a basic property of matter carried by some elementary particles that governs how the particles are affected by an electric or magnetic field. So to understand this definition, uh, then we have some uh, simulations and some activities. So after that you can understand it easily. The second point for the electric charge is the electric charge can be positive or negative. And it the same way as the conservation of mass, it also follow the same, the conservation of electric charge. Charge neither be created nor destroyed. All right. So now to understand the concept of the charging of an object, so we have to understand first the atom. Atom, the position of the elementary particles inside the atom. Okay, as we all know about that, atoms are building blocks of matter. Okay, everything on the earth is made up of matter, and matters are made up of atoms over there. So the important thing about the atom is we should know, because in this topic charging, we should know what type of charges are there, what type type of elementary particles and what kind of charge are there. So as we know all, inside the atom, we have a nucleus where the neutron and protons are there, and they have the charges. So proton is having positive charge, and the neutron, which is also inside the nucleus, they don't have any charge. And the electrons which are revolving around the nucleus, they are having negatively charged. Now the question is, if number of protons and the number of electrons are equal, in that case the atom is becomes neutral. If atom is neutral, that means whole matter is become the matter is made up of atoms, so the matter is also neutral there. So if everything is neutral, then how the objects get charged? So now to understand that concept, we have to look on this activity here. Electric charge, how? In this picture you can see, uh, when a balloon is rubbed with the wool, okay, what will happen? The electrons are removed from the wool and they are deposited on the balloon. It means what? Electrons from this wool, they will transfer to the balloon in that way. So initially the balloon was electrically neutral, like number of positive and negative charges were equal. Okay, and after rubbing, what happened? When the number of electrons increases, that means this balloon becomes excess of electron. So it gets electrified with one type of charge. What is that? Negative charge. So uh, and from the wool, as electrons are shifted to the balloon, so there is an excess of positive charge on the this one wool. So one objects get electrified, this one the positively charged and other one is the negatively charged. So this you can also understand by using this simulation, right, with the balloon and wool which is shown there. So we can understand the process of charging by friction or charging by rubbing with the help of this fate simulation. Right now you can see there are the two things, one is the woolen cloth and another one is the balloon. So electrically both are neutral because number of positive charges on both, they are equal on both the sides. So what we do, let's bring this balloon and rub with the wool. So what's happening here, the electrons are shifting or they are on the balloon. So now you can see there is the excess of electrons on the balloon, so it get negatively charged, and other hand the wool becomes positively charged because the excess of positive charge on the wool. So if I leave it, so the balloon will be attracted by this woolen cloth. So now why? Because of the force of attraction. At the same time, if you take the another balloon here and if you rub it, okay, then again it get the same charges. So now it would be repelled by this. So on the basis of that simulate this activity, we come to know about this balloon and this wool, what kind of charges are there. So balloon is said to be negatively charged. Why? Because of the excess of electrons on the balloon. And the wool is said to be positively charged because of the deficiency of the electron. Alright. So let's take one more example to understand this concept. Take glass and the silk. So when you rub a glass rod with the silk, what will happen? The glass rod becomes positively charged and the silk becomes negatively charged. The process again same. So electrons from this glass rod, they will shift to the silk in that way. So because of the excess of electrons, the silk becomes negatively charged, and this glass rod, due to the deficiency of electrons, it becomes positively charged. Now the question is, which objects get positively charged and which objects get negatively charged or becomes negatively charged? So how can we decide it? So to understand that concept, we have to follow this electrostatic series. So in this series, there are so many materials are written out there, starting with the human skin, fur, and to this one. At the end, it's ebonite is written there. So how how can we read this series to identify which material becomes positive and which one is becomes negative charge? So if you choose any two objects, two materials from this series, with the material which is closer to the top of this list, at the top of the list, that will lose the electron and become positively charged. And the second one is that material which is near to the bottom of the list will gain the electron and becomes negatively charged. So this process we can follow to identify which materials get positively charged and which one is negatively charged. In other words, we can say these the objects. If we choose any two objects, let's say take one glass and the silk, as we did the previous section. So glass is closer to this top and the silk is closer to the bottom one. So glass becomes positively charged and the silk becomes negatively charged. Alright, why? If we rub glass and the silk, that means that object no, which is closer to the top, that has weaker tendency to gain the electrons. Or in other words, if you take that silk one, so that has a stronger tendency to gain the electron. So any time you have to choose any two, like wool and the rubber. So wool is becomes positively charged and the rubber becomes negatively charged. The same process you can follow for any other thing. All right. So when the objects get charged, okay, then we can find the forces between these charged bodies, whether they have attractive force or repulsive force. For that, we have to use these two things here. The SI unit of electric charge we have to use as a Coulomb, and the charge on one electron just take always as 1.6 10 is to power negative 19 Coulomb. All right. So now we have two type of charges now, positive and negative. So if like charges, these are known as like charges, negative negative or positive positive, they will feel a force of repulsive, and unlike charges, they will attract to each other. Now the question is, attractive or repulsive, how much force is this? So Coulomb's law will help us to find the force between two charged particles. Now the question is, what is Coulomb's law? In 1785, a French physicist, Charles A. Coulomb, experimentally measured the electric forces between small charged pairs. So if on the right side of the picture, if we assume that, let's consider there are two charges here, negative and positive, and the charge on this negative sphere is q1 and it is q2. They are placed at a distance r. So let now they are unlike charges, negative and positive. So there would be a force of attraction between them. So to calculate this force, we have to use that Coulomb's law. So this experimental observation that was formulated in the form of Coulomb's law. So what is Coulomb's law? According to this law, the force of attraction or repulsion between these two charged bodies is directly proportional to the product of their charges q1 and q2, and the inversely proportional to the square of the distance between them. So that was on the basis of observation. So if you combine these two terms, we can write in this way, q1 q2 over r square. So if you remove the sign of proportionality, we have to write some constant k, and that equation becomes q1 q2 over r square. So this one is the general equation for the Coulomb's law, where k is a proportionality constant here and is known as electrostatic force constant. Now the value of K is given by this one 1 over 4 by epsilon naught, where epsilon naught is the permittivity of free space, and the value of this whole part, if you calculate by substitute, uh, if you calculate this value, then you will get approx 9 into 10 raised to power 9 Newton meter square per Coulomb square. So that means the final formula becomes 9 into 10 raised to power 9 Q1 Q2 over R square. So these equations we can use to calculate the magnitude of this force, where Q1 and Q2 are their magnitudes of these charges, and F is the force of attraction if they are unlike charges, and this F would be force of repulsion if these charges are same. Alright, so let's solve one problem based on the Coulomb's law. If you want to calculate Coulomb force between two alpha particles which are separated by a distance of 3.2 10 to the power minus 15 meter in air, so we can use Coulomb's law. How? So first we can write the equation, that is with numerical term 9 into 10 to the power 9. Only number we can write it here for the calculations because all are given in standard SI units, and the charge Q1 Q2 or R square. So we have to calculate only the magnitudes. So right now we can check they are the alpha particles. Both the charges are alpha particles. Let's take one charge, this one, and other is here. They are placed at a distance of 3.2 into 10 to the power negative 15 meter. So both have the same charge. Alpha particle, as you know, it's a positive charge. This one is also alpha particle, positive charge. They will feel force of repulsion. So to calculate this force, this one is the distance which is given in this question. To calculate this force, you can use Coulomb's, the equation of the Coulomb's law. Now, the question is, what are the Q1 and Q2? So to calculate the Q, the charge on these objects here, as we have alpha particles, so Q1 and Q2 both would be the same. And the charge on alpha particle is twice of the charge on electron. So we can calculate the charge on electron here. Now we know that one charge of electron 1.6 10 raised to power minus 19 Coulomb. So if you do these calculations, it becomes 3.2 10 raised to power minus 19 Coulomb. Alright, so we can use that in this equation. Distance is already given, so 9 into 10 raised to power 9, that is the charge Q1 and Q2 is 3.2 10 raised to power minus 19. You can make the square of this because they have the same charge, and the distance is given 3.2 10 raised to power minus 15 meter, and square of that one. So if you do these calculations, this 3.2 square is there, so you can cancel out this 3.2, both have the squares. So what is left here? 9 into 10 raised to power 9 is left. The power 10 raised to power minus 19, the square of this, it becomes 10 raised to power minus 38, and in denominator 10 raised to power negative 15, square of this, it becomes 10 raised to power negative 30. So if I write it in numerator, it becomes positive 10 raised to power 30. Alright, so now we can calculate it. So minus 38 and plus 30, we can add all these powers like this one. 9 into 10 raised to power 9 minus 38 plus 30. So the power would be add up. So what is left here? minus 38 plus 30, so negative 8 is left, and 9 minus 8 is 1, so 10 is to power 1, and that would be 90. And we are calculating the magnitude of force, so this would be 90 Newton. So that would be the force between these two alpha particles, which are placed at distance 3.2 10 to the power minus 15 meter, and that force is repulsive. Okay friends, that's it for today. If you like my videos, please subscribe this channel and click on the bell icon. See you soon with new videos, new topics, and definitely, as this one is my first video, so in future, okay, you will get very interesting videos. Bye bye. Have a nice day. Thank you.